An electron is placed at a distance of 0.4 meters from a fixed point charge of -6 millicoulomb. Show that the electric field sent due to the point charge at the position of the electron is 3.4 into 10 power 8 Newton per coulomb. What we have an electron here, we have a negative charge over here, and he is asking you what is the electric field sent at this point. So how do I do? Simple. So what we do is electric field sent E is given by the formula KQ divided by R square. What is K? 9 into 10 to the power of 9, which you can get from your data booklet. And Q, what is the value of Q? Q is 6 millicoulomb, -6 millicoulomb. Okay, let me write -6 into 10 power -3 divided by R square. What is R? 0.4, which should be 0.4 square. When I do this, 9 into 6 into 10 to the power of plus 9 minus 3 is 6. 9 minus 3 is plus 6 divided by 0.4 square 0.166. Of course, you would have considered the negative here. I'll put the negative sign here. So which should now be equal to, let us do the calculation. Should now equal to 9 into 6 is 54 divided by 0.16. It should be 337.5. 337.5 minus 337.5 into 10 to the power of 6 should now be, I can now write minus 3.4 into 10 to the power of 8 Newton per coulomb. So since we have this as an electron, so what can happen? This charge, what we have here, so the electric field here is going to be repulsive. So I will just remove this negative sign over here and put this positive. I hope you got this. See, this is a positive, this is a negative charge, and this is acting on one more negative charge. So the electric field is going to be repulsive, and the electric field is directed away from the negative of the charge, and the electric force is going to be repulsive. Okay, and as a result of it, I will consider this as a plus 3.4 into 10 power 8. Okay, if it was an attractive field, then I will put this as a negative value. Okay, if it is a repulsive field, I take this as negative, the positive value. Okay, calculate the magnitude of the initial acceleration of the electron. Initial acceleration. What do we do? Apply whenever there is an acceleration, use F equal to ma. Okay, Newton's second law, F equal to ma. And what is the electric force acting here? Electric force is nothing but Q times E, right? Q times E, which should now be equal to 1.6 into 10 power minus 19 multiplied by 3.4 into 10 power 8, right? So now this M, what is M here? M is the mass of the electron. I want to get the value of A. A should be 1.6 into 10 power minus 19 multiplied by 3.4 multiplied by 10 power 8 divided by 9.1 into 10 to the power of minus 9, 31. Okay, this is the mass of an electron. You can get it from the data booklet. So when you substitute all this and finally get the answer, the calculator gets 1.6 multiplied by 3.4 divided by 9.1. I get it as 0.597, which is 0.58, right? 0.58 multiplied by, here it is 19, 8 and 31. Let me do this also. It's easier. So it becomes minus 19. So it becomes minus 19 plus 8, and this is minus 31 becomes, goes there, it becomes plus 31. Plus 31. So the answer is plus 20. Plus 20. This meter per second square, or maybe I can now write this as 5.8 into, oh my god, 10 to the power of 10. Let me take 10 power 19 meter per second. Let me just 10 power 19 per second. Okay. Now let me proceed further. Describe the subsequent motion of the electron. What happens to the motion of the electron? See, the acceleration, we got this as 5.8 into 10 power 19 meter per second square. See, this is your negative charge. This is your negative charge. This was the electron initially. Now, because of this acceleration, what will happen? Velocity will increase. Velocity will increase. See, this is for 3 marks. Okay, you cannot just say so much. Okay, so this first point. Second point. Second point, what will happen? Now, this electron will move here after 1 second, let us say. When it is here, now the distance here is larger. Okay. When the distance becomes larger, the distance between the electron and the negative charge is larger, then what can happen? The electric field which goes as kq by r square will reduce. And then this reduces, what else can happen? This implies acceleration will reduce. Acceleration will reduce. Okay, this can happen. And lastly, okay, acceleration can reduce. Though the acceleration reduces, what happens to velocity? Velocity, the rate at which the velocity increases also reduces. See, the velocity will not reduce. Remember, there is no brake applied on the electron. Okay, only thing is, when I push the accelerator pedal, I am pushing it slowly. Initially, it is going very faster. Then still I am making it to go faster, but it's not at that rate. Okay, so that is what it happens. So the acceleration can reduce. The rate at the velocity increase also reduces, but velocity is still increasing. Okay, this will complete the whole 3 marks. Okay, thank you. Let us